All right, so I'm working with the last one in the packet, so Algebra 2, Unit 2, Topic 2 review. A lot of twos. So it says let f of x be equal to x plus 3, x plus 1 to the n power, and then x minus 2 to the second power. So it says if the polynomial function f has a degree 6. So what I'm doing here is I'm counting how many x's there are. So 1, there's 2 here. So if I need there to be 3 to add up to be 6, I'm going to need that n to be 3. All right, just as simple as that. So what is the multiplicity of the zeros of f at x is equal to 2? And what we do here is we take a look and we see what the zeros would be for this problem. So x is equal to negative 3 for that first, x is equal to negative 1 for the second, and x is equal to 2 for the third. Now, how many times, what it's really saying is that how many times is that x equals 2 is appearing? And since we have this little squared there, that means it's appearing twice. So we're going to write that as 2. If this was like x minus 2 to the fourth power, then the multiplicity of the 0 would be 4. So it's based around the exponent for the specific root. Wow, a lot of wasted space in there. So it says let g of x be a polynomial defined by g of x is equal to negative 2, x plus 5, x plus 3 to the second power, and x is equal to 4. So the first thing I'm going to do here is I'm going to focus on the end behavior. So more specifically, since it is negative, that's going to play an important role in determining the end behavior for this polynomial. The next thing I'm going to do is I'm going to figure out the degree for this by also writing down the roots. So x is equal to negative 5. There is going to be an x is equal to negative 3 and x is equal to 4. Now I'm going to put off to the side for the 3 that this is going to be doubled up on the 3. So that means that altogether we have a fourth degree polynomial. Okay, so we know that the leading coefficient is negative. We know that it is a fourth degree. So what that means in terms of the graph, we know that it comes from, if it is a negative coefficient, it comes from negative infinity. Okay, I should say that it comes from negative infinity and then leaves going to negative infinity. So the question here is, what is happening in the middle? So since it is a fourth degree, it can end up having 3 turns at most. It could have a little less, but at most it could have 3 turns. So as x goes to negative infinity, g of x is going to be going to negative infinity. Same thing for the other one. It's a terrible infinity sign. Okay, then it says draw a rough sketch of this. Now the nice thing, since you guys will actually have a calculator for this, you can actually figure this out on your own by just typing into your calculator. But since I do not have a calculator and I want to try and do this on my own, I'm going to write down my roots, or also known as my zeros. So I'm going to write down negative 5, negative 3, and 4. Now the things I know about this, 1, I know comes from negative infinity, so I'm going to start it here. I know that it goes through 5, so I'm going to go through 5. I know I'm going to have to come back and hit that negative 3, so I'm going to hit back in negative 3. Now what's going to happen normally, we would actually go through the negative 3, but since it doubled up on that negative 3, we're actually just going to bounce it back up and cover the 4, and then it's going to come back down. Now the reason why it doesn't hit anywhere in this specific section is because there's no other zeros there. So what's going to end up happening is that it's going to just, in a sense, bounce back up, and then the next time that's actually going to pass through the graph is going to be at x is equal to 4. So that is our quick sketch for that. And you can always graph this to get a real kind of look at what this graph is supposed to be. Maybe it's not as sharp of a turn around there, but for the most part, in this problem, it's going to look somewhat like this. By the way, you can never really figure out where the height of this unless if you know a little bit of calculus to kind of help you along with this type of problem. But we're not there yet. Okay, so Ivan performs the polynomial division below, also known as long division. Okay, so it says x minus 1, a factor of x cubed plus x squared plus x minus 3. Justify your answer. So they actually run through all the steps of actually figuring out how to do long division, which is kind of nice. And then since I'm left with a 0, that means that this right here is going to be my remainder, and there's no remainder, so that means that x minus 1 is a solution. So we could say that 0 is a remainder. You can also say that you can set up the value as x squared plus 2x plus 3, and then times x minus 1, and that's going to end up giving us x to the third plus x squared plus x minus 3, which is, in a sense, the same thing as the opposite of division, right? It's those values are, they can be multiplied together to give you x to the third plus x squared plus x minus 3. Right, because if I were to do something kind of simple, 6 divided by 2 equals 3. So if I were to do 2 times 3, that would definitely give me 6. So we're just doing kind of the opposite backwards, right? This is the number that I'm being divided by. This is the top number. This is the quotient. So same kind of deal. Okay, so it says write the factorization of x cubed plus x squared plus x minus 3. So since I actually know that that is actually a solution, so x is equal to 1, I'm going to do good old synthetic division for this to just kind of make my life a little bit easier when trying to solve these problems out. Actually, I already know what that is. That's going to be x squared plus 2x plus 3. So I'm left with x squared plus 2x plus 3. And right, that's going to be x minus 1. Now, can I factor that any further? So two numbers that when I multiply, I get 3, but when I add, I get 2. And doesn't look like that is actually possible. So what I'm going to do here is this is going to be as factored as it can be without going into some complex numbers, ones dealing with the I solutions. I can show you what that is when I solve this last one. So when I solve this, I'm going to write this as x minus 1, x squared plus 2x plus 3 equals 0. And I'm going to say x is equal to 1 for this specific part. But for this equation, what I'm going to have to do is I'm going to have to do some kind of tricks to kind of get this down further. So what I'm going to do is I'm going to write this as x squared plus 2x plus 3 equals 0. Bring the 3 over. And do some, actually I want to do some good old, or not synthetic, I want to do some good old completing the square. So I'm going to place a 1 here. The reason why is I'm going to do 2 divided by 2 and then square it. That will give me my new c value. So that's going to be 1. So I'm going to add 1 to the opposite side. I'm left with x plus 1 squared is equal to negative 2. Square root both sides. I end up getting x plus 1 is equal to I square root of 2. Bring over the 1. Oh, don't forget about plus and minus. And next is going to be equal to negative 1 plus or minus I square root of 2. So it gives us 2 complex solutions and then 1 real solution out of this. So just to kind of make some sense out of this, right, there's a 3 right there. So that means that I can have 1 real solution, 2 or 3 real solutions, but altogether I should have 3 solutions together. So in this case, this is going to be my real solution, and these are my 2 non-real solutions. And if I were to plug these values actually back into this problem, I could actually, end up getting zeros when I place in those x values. Okay, moving along. So it says divide p of x by x plus 3. So there's multiple ways of doing this. I'm going to show you, I'll actually show you both ways, both synthetic and long division. So I'm going to start off with synthetic. So I'm going to write x plus 3 is equal to 0. What I'm really trying to do is I'm trying to find out the 0 for the x plus 3. And that's just going to leave you with x is equal to negative 3. So negative 3 is going to be my number. The next thing is I'm going to write down the leading coefficients of this polynomial. That would be 1, 5, 14, and 30. Okay, so the first thing I do is bring down the 1. Then the next thing I do is I'm going to do negative 3 times 1, this number right here. That gives me negative 3. Add those two together, so I get 2. Then do it again, negative 3 times 2, which gives you negative 6. Add those two numbers together, so that gives you 8. Then do it again, negative 3 times 8, which ends up giving you negative 24. Negative 24, and I'm left with 6. Now, if I was doing synthetic substitution, that means that if I were to plug in x is equal to negative 3, I would get the result for capital P of negative 3, we would get the value 6. So that means that it doesn't divide evenly. So I would write this as the following. So this is going to be my remainder. This is my constant. This is x, and then this is my x squared. So I'm going to write this as x squared plus 2x plus 8 plus 6 over, and then I write the divisor by x plus 3. And there is my answer. Now, if I was taking the root of long division, I'm going to write this as x plus 3. I'm going to go through this relatively quick. X to the third plus 5x squared plus 14x plus 30. So I'm going to only focus on the first terms as I work on my long division completely, working it down. So what times x gives me x cubed? So that would be x squared. So I'm going to place an x squared there. So I'm left with x cubed plus 3x squared. Then I subtract those values. So those cancel. 5x squared minus 3x squared, which leaves me with 2x squared plus 14x. What times, now I'm working with 2x squared. So what times x gives me 2x squared? That will be 2x. So I'll write 2x squared plus 6x. Subtract those. So those cancel. And then 14x minus 6x, and that gives me 8x. Bring down the 30. What times x gives me 8x? That would be 8. So that leaves me with 8x plus 24. And I'm going to subtract that. Those two cancel. I'm left with 6. So to finish this up, plus 6 over x plus 3. And some of you guys might have noticed that a lot of these different types of values, like the negative 24, the 24 right there, and the negative 6, and the negative 6, all kind of correspond. So really you're doing long division in synthetic or synthetic in long division. So is x plus 3 a factor? No, because we had a non-zero remainder. Using your work from part A, what is the value of p of negative 3? And that's what I was talking about before. That's going to be 6, so that would be 6. Okay, so I am definitely going to have to use my calculator for this problem, so to kind of help you along with this. Okay. Oh, they actually have a picture for you. But anyway, so Robert needs to make a small box to hold paper clips. He has an index card that is 10 centimeters by 16 centimeters. He cuts equal squares out of each corner and folds it up the sides to show as shown below. So this is really kind of the setup. So write an expression for the volume of the box as a function of x. So I'm going to write this as, well, first of all, volume of a rectangular prism is going to be the following. It's going to be length times width times height, or we could say the capital B times H, right? Capital B represents the base area. But since we're talking about like a normal rectangular prism, I can just do length, which in this case would be 16 minus 2x, times 10 minus 2x, and then times x. So 16 minus 2x, 10 minus 2x, and x. And to be honest, it really doesn't actually matter the order in which you write those multiplications, because multiplication is what we call commutative. So I could say 2 times 3 is equal to the same exact thing as 3 times 2. 2 times 3, 3 times 2. All right, so what is the domain of this? Right, so what ends up happening here is when we are working with some type of real life example, right, we can have x values that are going to go into the negative or into the positive, but what ends up happening here is we end up getting some type of issue with actually not having a physical thing anymore. So, right, if I were to say x is equal to negative 2, right, I can't have a negative 2 height. So what I'm going to do is I'm going to set up, in a sense, I could set up my graph, but it looks like that they actually have the graph of it for you. So I would say the domain is going to go from 0 to 5 for the specific problem. And I can see right here that my domain is going to go from 0 to 5. Now, if it goes below it or above that, we'll get into negative territory in terms of the v of x value, which also means that this whole figure itself doesn't actually exist, or you actually end up getting a negative volume, which is kind of weird. Okay, so it says, what size square should be cut out of the index card in order to maximize the volume of the box? And then what is the volume of that of the box? So I can technically see the height, but most likely you probably could figure out that it's going to be that high point. So what I'm going to do here is I'm going to use my trusted Desmos. And I'm going to type in that equation. And so you can use your calculator as well to help you along with this. Right, you would just go to second trace, which is calculate, and you will look for the max. And we've done that a couple times in class. So y equals parentheses 16 minus 2x, close parentheses, 10 minus 2x, close parentheses, and then an x again. Now you'll notice here that this graph actually looks more like our cubic function. And actually, to tell you the truth, it is a cubic function. So why was my domain only kind of locked into, in a sense, this kind of area right smack in the middle? And the reason why is because when it dips down below, right, that means I technically have a negative volume, right? And so that's not actually possible when it comes to these types of problems. So I'm really locked in only between 0 and 5. So what I'm going to do here is I'm going to find out the height. It looks like that the height is going to be, so this is going to be 2 comma 144. Now to understand the meaning of that specific point, this means that I want to cut out 2 by 2 centimeter squares from this index card. So what size squares? So 2 centimeters by 2 centimeters. That's what the x value represents because that's what it represented in this equation. And then the 144 is acting as my maximum amount of volume. So we would say, what is the maximum volume? 144. And since we're talking about volume, we would be talking about centimeters, but cubed. So 144 centimeters cubed. All right, thank you. I am finished with the review for Honors Algebra 2 for quarter 2. If you guys have any questions, please comment down below or also comment on my Discord server. I'm more than happy to answer any types of questions or go through any more of these types of problems with you if you have any specific types of questions. All right, thanks.